Hi, welcome to clickmeproject.com. This video will lead us to the demo of a decentralized service discovery approach on peer-to-peer network. Service-oriented computing is emerging as a paradigm for developing distributed applications. A critical issue of utilizing service-oriented computing is to have a scalable, reliable, and robust service discovery mechanism. However, traditional service discovery methods using centralized registries can easily suffer from problems such as performance bottleneck and vulnerability to failures in large-scale service network, thus functioning abnormally. To address these problems, a peer-to-peer based decentralized service discovery approach named COD4S. COD4S utilizes the data distribution and lookup capabilities of the popular COD to distribute and discover services in decentralized manner. Data availability is further improved by distributing published description of functionally equivalent services to different successor nodes that are organized into virtual segment in the COD4S circle. Based on the service publication approach, COD4S support quality of service aware service discovery. COD4S also support service discovery with wildcard. Network creation is the first thing in the peer-to-peer network. Here the maximum size of the network is having 10 peers. Then only the network is created. The service creation is the next process. The user first gives the service name and then the user must give the 3 service descriptions. The service creation is the user defined one. Then the user can create the service as much as the user likes. The service description contains 2 main parts. They are the service identifier and the QoS specification. In service identifier, there are 2 main parts. They are functional bits and provider bits. The functional bits are the hash value of the service and service description. The provider bits are the hash value of the total service name and the service description. In quality of service, the numeric quality of the service is specified. The data availability is the peer is very important. The request from the user is sent to the peers. At that time, the service availability is very important. If the service is not available means, then the service publication have some problems. The data availability in all the peer are not needed, but it have many problems. Many replications in many peers are occupying large storage capacity. So the service publication in COD using some functionalities to publish the data in the peers. In service query, the user can know all the service available in the network. Then the user can select any one of the service from that. The service query having 2 types. They are service specific query and query with wildcards. In service specific query, the query contains the service name and service description. But in query with wildcard, the query contains only the service name. Then the user can know the peers having particular query. Then the functional bits are generated for the particular query. And then the provider bits are also generated for the client request. Then the comparison in between the functional bits and provider bits of the user and the functional bits and provider bits of the service distributor. If the 2 functional bits and the provider bits are equal means, then only the service is distributed to the client. The quality of checking is very important in the service. If the quality is satisfied in the user request means, then the service is distributed. The peers having the service is displayed and then the client can get the service from that peer. Now let us see the demo of a decentralized service discovery approach on peer-to-peer network. First of all, click the service computing button. The service computing has become a cross-discipline that covers the science and technology of bridging the gap between business service and IT service. Now press next. Here the user have to select the number of nodes in the network and then press the create button. Now the nodes in the network or the peers in the network is created. Click OK. Press service. Now press service on or off. Here the service is created. The service contains the service name and the service description. First of all, enter the service name and now enter the service descriptions. There must be 3 service descriptions and then press the service off button. The service name and the description. Here the functional bits are generated for the service name and the service description, and also the provider bits are also generated. The provider bits are generated by using the combination of the service name and the service description. And now press the quality of service specification. In quality of service there are 2 things. They are Boolean quality of service and numeric quality of service. In Boolean quality of service, the user must give only the Boolean values, that is 0 or 1. If the user gives 0 means then the service is not available to any of the user. If the Boolean value is 1 means then any of the user can get the data from the network. And then the numeric quality of the service, it means that the number of availability of the service in the network is described. And now press publication. Now the data are stored. Now press OK. Now the service is distributed to the peers in the network. For that, click publication. This service is distributed in only one peer in the network. Press show peers list. It contains the peers list. The peer 6 contains the service. If you want to create the new service means, and then press service creation button. Again you have to press service on or off button. Now enter the service name of the new service and then enter the service description for that service. Press the search on or off button. The functional bits and provider bits of the service name and the service descriptions are generated. It is generated by using the hash function. Now the hash values are generated. Click OK. For this service also you have to specify that the quality of the service. And now the service is get ready for the publication. Now the service is distributed in only one peer in the network. Press show peers list. The peer contains the service is peer 7. Now press the query button. Now there are 3 services in the network. They are cars, mobiles and computers. The user can select any one of these services. For that, copy the service name from here and paste it in this place. Then only the user can know the service description for that particular service. Now press query. There are 2 types of queries for the user request. They are service specific query and the wildcard query. For service specific query, the user must enter the service name and then the user must enter the service description. And now click service specific query. Now the hash value is generated for this service name and the service description by the user. And then we have to compare this. Now press successor nodes. Successor node means the number of peers in the network. And then now press matchmaking. Here the hash value of the user request is matched with the hash value in the peer 7. And now press preceding nodes. Here the preceding nodes are the nodes that did not contain the particular service, and then the graph is generated for the number of peers and then the number of services. Now the user can also know the service availability. The second one is the wildcard query. Here the user have to enter the service name only and then press the wildcard query. For this wildcard query also, the hash value is generated for the service name, and then we have to compare it with the hash value in the network. Here also the successor nodes are there. In successor nodes, the number of nodes that containing the number of nodes in the network is displayed, and then in matchmaking the number of peers that having this service is displayed. In preceding nodes, the nodes which does not having this particular service is displayed, and now the service availability of the user is displayed. This graph shows that the number of peers and the number of service